I will. Good afternoon, everyone. Good afternoon, students. Good afternoon, Odi. Good afternoon. Okay, so today we will now have to start with a new topic. Okay, we are done with transformations, and it is also timely that today is a rainy day. Okay, but anyway, the rain has just stopped, but so therefore temperature is colder. Okay, so our topic now will be about polynomials. Okay, so please listen carefully because polynomial is quite difficult if you do not understand, but it is easy if you do understand. Okay, so this is just a matter of listening and participating also so that you will get what we are going to discuss. Okay, so we will now have chapter 3 of your book, and chapter 3 is page 43 of your book. Okay, so if you want to have a reference, then you can open that on page 43, all about polynomials. Okay, so what are these? What is a polynomial? Okay, say Haruka, please read since you are the one to join. Polynomials
comes from two Greek words. Poly means many and nomials means terms. So polynomial means many terms. It consists of terms in the form of ax, where n is a non-negative integer and a is a real number known as the coefficient.
Okay, thank you. Now, polynomial comes from two Greek words. Poly means many and nomial means terms. So they are combined, so many terms. So that is why it is important that we should understand what is the coefficient and what is the power or the exponent. Okay, exponent we usually call that one as the power. Okay, so you have here terms, consist of terms in the form of a, x, n. So just like here, this is one term. Okay, so this is one term, therefore it is called a monomial. Okay, so this is a type of polynomials where there is only one term. Okay, 5x to the power of 4 or 5x exponent 4. Okay, but usually we call it power. Now here also, this is only one term and the power is 2. Power can also mean the degree, okay, but we will discuss degree later. Okay, and one qualification is that n should be a non-negative integer. So therefore, the power should be positive. Okay, and n, okay, is a non-negative integer and a is a real number. What is a real number? Those numbers on the number line, positive or negative, are all real numbers. So negative 5 is real, negative 3, positive 5 is a real number. So that is what we call as the coefficient. Again, these numbers are called the coefficient, and the x, the a, what else, the z is what we call as the variables. And of course, the power is exponent. Okay, so just remember that one. The variable, the coefficient, and the power. Again, the number is the coefficient, the letter is the variable, and we have the power, which should be a positive power, not negative, because if negative, then that is not a polynomial. Okay, we will have that one in another subject. So all power should be positive in this topic. Okay, so there are types of polynomial: monomial if only one term, binomial like bicycle, two wheel, binomial means two terms. Example, 3x cubed, okay, this is one term, plus 5y squared. So these are two terms. So binomial. Trinomial means three terms. You have here, for example, this 2xy to the power of 4. That is one term separated by a positive or a negative sign. 5x squared, another term separated by either positive or negative sign, and then you have the third term. So that is why it is called trinomial, because it has three terms. Okay, so that is all about, or those are polynomials. Okay, so take note of that one. The coefficient is the number, which is a real number. Variable is the letters, and the power is the exponent, which should be a positive. Okay, going next, and we will talk about degree. So what is a degree? Okay, Poon, you read what is a degree? The degree of a polynomial.
The degree of polynomial is the largest exponent in the polynomial. In a polynomial with multiple variables, it's the largest combined exponent in a term is the degree of the polynomial.
Okay. Okay, so let us take that one into an example. Okay. Okay, so the degree is the highest exponent or the highest power. Okay, so that means that in every term, you have also that power, and the biggest power of exponent that determines the degree. Okay, just like here, x to the power of 4. So therefore, it is, the degree is 4 because that is only 1, so the highest power. Now, what if you have here 3x squared plus y5? Now, Grace, what is the power, or what is the degree in here? 3x squared plus y5. What is the degree? Yes, we said that the degree is the highest exponent. So what is the degree in here? The degree is
5.
5, okay? Because 5 is the highest exponent. 4 in here because it has 4 as the highest exponent. Now, in a polynomial with multiple variables, meaning many variables in it, the largest combined exponent in a term is the degree of the polynomial. What does it mean? Take a look. You have here 4a cubed b 5 plus 5b plus 6c squared d. So these are now combinations of variables. So this is what we call as multiple variables. So therefore, the degree in here is the highest power combined. So 3 and 5 combined is 8. Here only 1, which is b. Here 2 and 1 combined is 3. So therefore, the degree with this polynomial is 8. Why 8? Because we combine the exponent 3 and 5. Because this is only one term. If we take this one. The degree here is only 3. We have here 2 and D has 1. So only 3. So therefore, the degree in these polynomials combined is 8 because you have there A cubed and then B5 combined. Okay, clear? What about the others? Get? Okay, do you understand? Okay, because we will now go to a more complex one. And that will be after introduction of that polynomials, we will now go to addition and subtraction. Take note, addition and subtraction are just having the same process, the same step. Okay, but only when we minus, if there are 2 negatives, it will become positive. Okay, so we will go to that later. Okay, so continue. Okay, the degree of a polynomial here. Okay, this is also another example where we name the level or the degree. Linear means 1, which is having power of only 1. So you have here x plus 1. Quadratic, the highest power is 2. Okay, quadratic. Cubic. Okay, so from the name itself, the power is 3. Quartic or 4. So the highest power is 4. So therefore, the degree is 4. And we have here quintic, quinta, penta, so meaning 5. So the highest power is 5. So again, the degree is determined by the highest power of the term. And if multiple terms, then we combine the exponent of each variable. Okay, so that is very clear. Next, we now go to the steps in adding or subtracting. Okay, by Kao, please read that one. Number 1.
Group terms that are similar, like how do we know if it's similar or like? Check if variable and exponent are the same.
And number 2. Operate. 3.
Arrange in this descending
Descending.
order according to degree.
Okay.
Box
And number 4.
final answer.
Okay, box your final answer. So these are the steps in adding or subtracting. Now there is only one important point that we should remember. That is to group similar terms. Similar means the same terms. Now, how do we determine if they have the same term? First, you must check that the exponent are the same. Okay? And of course, the variable also are the same. So that means you check whether the variable and exponent are the same. So they are like terms. If they are different, then that is not like terms. Okay? So here, example. Like terms, like terms are terms that contain the same variables with corresponding variables having the same power. Now in here, 3x squared plus 4x plus x squared minus 2. Poon, what are the like terms in here? 3x squared plus 4x plus x squared minus 2. What are the like terms there? Yes, Poon?
Yes.
Okay, what are the like terms in here in this example?
I think 3x2 and x2.
Okay, so the only like terms here will be 3x squared and x squared. Okay, because 4x, though they are the same variable x, but the power is not the same. So, and 2, -2 is a constant. So therefore, 3x squared and x squared there are the only, okay, like terms. Okay, so you are correct. The terms in the expression are 3x squared and, okay, so the same, like or similar, unlike or dissimilar term. So as you can see in here, Odi, 4xy and 3xy, similar or dissimilar? Odi, 4xy and 3xy, similar or dissimilar?
Similar.
Similar. Okay, very good. Similar, because they have the same variable, they have the same power. Next. Next. Satang, 7xy squared and 5x cubed, similar or dissimilar?
Dissimilar.
Dissimilar. Okay, it is not similar. It's very obvious. It is not similar. Why? Xy squared here, and we have x cubed here. So dissimilar. Okay, Alice, 2x squared and minus 4x, similar or dissimilar? Alice? Hello, Alice, are you there? Oh, MG, where is Alice? Okay. Okay, so I will answer. 2x squared and minus 4x is dissimilar. Okay, take note, the power here is 2, the power here is 1, so not the same. Negative 3x squared and 5x squared, similar or dissimilar? Alice, again, are you there? Okay, Haruka, similar or dissimilar?
Similar.
Similar. Okay. So again, I am focusing and I emphasizing that one because that will be the basis for addition and subtraction. Okay. Next here. Okay, so if we analyze that expressions, 7x squared plus 8x minus 2y plus 8 minus 6x. Okay, so we have there 7x squared plus 8x. So therefore, the similar terms there will be, okay. So again, 8x and negative 6x, similar. Negative 2y, negative y, similar. And the answer for number 3, y squared and 2y squared are similar because others are not having the same power. Okay, so that is just easier to understand. Now, to simplify these expressions, we should combine like terms by adding their coefficients. Okay, so that is important. We will add their coefficients. And of course, we maintain the exponent. And then rewrite the equations with like terms combined. And then we arrange that one in descending order according to the degree. So the biggest degree, the biggest power, next, second biggest, next, third biggest. So descending order from biggest to lowest degree. Okay. So when adding polynomials, we only combine like terms. Okay. So here, 2x squared plus 3x minus 4 plus 4x squared plus 4x plus 8. So as you can see in there, x squared, so same. 3x, 4x, similar. Negative 4 and positive 8, similar. So therefore, we are now going to combine like terms. So we may add these polynomials vertically or horizontally. Okay, write each polynomial on a separate line, thus keeping them separate without using parentheses. Put like terms beneath each other, even if to do so you must rearrange the terms of the polygon or the expression. So in that example, you have there 2x squared plus 3x minus 4 plus 4x squared plus 4x plus 8. So what do we do again? We will combine. So that is why 2x squared combined with 4x squared combined. So that is why you get 6x squared. 3x and 4x combined. Then you get 7x negative 4 plus 8. Different sign, so therefore we get the difference of the two numbers, taking the number with the biggest or the bigger sign as is. So therefore, negative 4 plus 8 is positive 4. Okay, so that is just what we do when it comes to addition of polynomials, addition or subtraction. But what is important there is that you must understand like terms, especially when it involves multi-variables. So meaning many variables in one term, multi-variables. Okay. So far, do you understand it? Okay, so far, do you understand addition of polynomials? Yes or no? Yes, okay. What about the others? Okay, that's good. Okay, so we will continue again. That is just combination of similar terms. Okay. Okay, here we will take this example. We can use the vertical method or the horizontal method. Number 1, 3x squared plus 3x plus 3 plus 4x squared minus 2x plus 1. So combining 7x squared and 4x squared, we have 7x squared. And 3x minus 2x, we have there x plus 4, which is 3 plus 1. So that is why we get that answer. Or we can use also the vertical method. Okay. Alice, are you now there? Alice? Oh. Okay. So, by cow, okay, what is the answer to this one? Combine. Y squared minus 8y plus 10 plus 3y squared plus 8y plus 10. What will be the answer?
For y raised power of 2
Okay,
plus
4y squared
20.
plus 20.
20.
Okay, very good. That is the correct answer. Take note, y squared and 3y squared combined is 4y squared. Now here, negative 8y and positive 8y can be cancelled out. That means they are equals to 0. So therefore, it is cancelled. And then we have here 10 plus 10 is 20. Okay, so that is correct. 4y squared plus 20 is the answer. Okay. So the same, that is the correct answer. Vertical method, okay, that's just easy. Vertical method is just the same. So we still get 4y squared plus 20. Okay. The third, okay, that one, Poon, what will be the answer? 3a cubed plus a 7a minus 1 plus 3a squared plus 3a minus 4. Poon, okay, Poon and Haruka, you solve. What is the answer?
Um,
Yes.
3
3a less to the power of 3
Okay.
plus 3a less to the power of 2
Plus.
plus 10a minus 5.
minus 5.
Okay. Okay. Why am I giving you this one? Now take note and remember that it is arranged in order of degree. Descending order. So that is why, as you can see in here, the power is 3. Next, the power is 2. Next, the power is 1. And of course, the constant. The whole number or the constant should be the last. So that is why it should be written in descending order according to the degree. Okay? So that is it. That is the answer of that. Okay, next. If we use the vertical method, okay, so we get the same answer, but take note in here, a cube and a square. So a square don't have same term. A cube also don't have the same term because they are having different exponent or power. Okay. Now, what about subtracting polynomials? Okay. We said addition, subtraction, they are just having the same step. We just add like terms. But remember this one. This is in subtraction. Remember this one here. Okay. Please read this one. Haruka, you read first.
Remember to change the signs of every term in the second polynomial when you remove the
Bracket.
bracket.
Okay. So remember to change. Why? Because when two negatives here, for example, this one and another negative in here. Okay. The answer will be positive. So negative and followed by another negative, it will now become positive. Okay. So that is the only important point in there that you should remember. Change the sign inside the bracket. Okay. In subtraction of polynomials. So in here, you have here negative. So therefore, this becomes positive in here. You have here negative. So therefore, it becomes positive. And then you have here positive here. Since you have there minus, so therefore this becomes negative. Okay, so that is why it becomes negative in here. And then you have the negative and another negative, so therefore this becomes positive, the constant. Okay, so combine it together, the same as addition, we just combine it together. So you have here 8x plus 4 8x to the power of 4 plus 13x to the power of 4 combined. Negative 3x squared plus 3x squared combined. And negative 11x and negative 2x combined. And we have also the constant combined. Okay, so therefore, we have now this answer 21x to the power of 4, and this one is cancelled out. Positive and negative 3x squared, so cancel out. And then negative 11x combined with negative 2x, that becomes negative 13x, and combine also the constant, negative 3 combined with positive 17, so it is positive 14. So that is now your final answer. Again, that is the important point when we go to subtraction of polynomials. Change the sign in the negative, or change the sign in the bracket, and then combine like terms. Sorry, excuse me. Combine like terms. Okay. So did you get it so far? Okay, so did you get it so far? Any question regarding addition and subtraction of polynomials? Just remember, combine like terms, but in subtraction, change the sign inside the bracket and then combine with the first polynomials to be added. Okay, that is the only difference in there. Just change the sign of those terms inside the bracket and then combine with the other polynomials. Okay, so I guess you understand, or any question regarding that one? Because we now go to our activity. Okay, for your task. But we will start it now so that we can have. Okay, so please take out your workbook and okay, there you go. Okay, take out your workbook and open to page 32 first. Exercise 3.1 and 3.2. Okay, we have 4 minutes. Okay, so page 32. Page 32. Number 1, are these polynomials? Yes or no? Again, number 1, are these polynomials? Okay, no need to explain, just to say yes or no. Letter A. Letter A. 6y squared minus 5x. Is it a polynomial? Yes or no? Poon? Yes or no? Letter A, number 1. 6y squared minus 5x. Is it a polynomial? Yes or no?
Teacher, what
Yes.
page?
Page
What page?
32. 32. Okay. Okay now?
No.
Oh. Okay, Haruka, you have it? Page 32?
No, I mean I can find it. And the answer is no.
Uh-huh. Letter A. 6y squared minus 5x. Is it a polynomial? Yes or no?
Yes, sorry.
Yes. Okay, so letter A is yes. Letter B, 5x over y squared. Haruka, polynomial, yes or no?
No.
No, because y squared is having a negative exponent. Take note, y squared is having negative exponent. That is just the same as 5x y square y to the power of -2. Okay, but written in reciprocal. Same is true with letter C. Okay, so that is no. Number 2, we still have 2 minutes more. Number 2, for each polynomial, state the variables, exponents, and constants if available. Letter A. First is variables, exponents, and constants. So letter A, 5xy plus 10. So the variable is x and y. The exponent is 1 and the constant is 10. Again, letter A, number 2, 5xy plus 10. The variables are x and y. The exponents are 1 and 1. Okay, x is 1, y is 1. And then the constant there is 10. Letter B, 2ab squared plus 5c. Okay, so the variables we have a, b, and c. The exponent for a we have 1, b is 2, and c is 1. And the constant is none, 0. Okay, so there is no constant for letter B. Oh, okay, so we have less than a minute. Okay, so please continue that page 32 and 33 and also page 35 for subtraction. Okay, so please bear with us. We have no more time. So I thank you all for your participation in our class of today. Thank you so much that you are all good in participating and in our discussions. Okay, so thank you and see you again on the next class we have. Okay, so bye-bye and you keep safe always.